In this section, we are learning about points of intersection of lines. So let's do a couple of examples. We have a line here called A, and it is 2x minus 4. If we were going to graph it, we would start down below in the section we can't see down here. And first, we would graph the y-intercept, and then we'd use the slope to graph the line. So this question asks us, what's the point of intersection between line A and line B? Y equals 2x minus 4, and y equals 0.5x plus 2. So we just follow the lines with our eye until we find the point of intersection. And once we have that, we need to figure out what this point is. So we look for the x-coordinate. The x-coordinate is 4. And the y-coordinate. And the y-coordinate happens to also be 4. And that's it, that's all. You could write a sentence. The point of intersection, yes, you can use a short form, is 4, 4. Okay. We could be given the equations. What do we need to do first? First thing, let's graph it. So let's do this equation in blue. Minus 2x plus 3. What do we start with? The y-intercept. We have to start at a point. Okay, now we need to go down 2 and over 1. Down 2 and over 1. Okay, let's draw a line through this. Great, so we have that line. Now let's do the other line in red. So start with the y-intercept, minus 3. And there's no slope written here. So what does that mean? Well, that means there's an invisible little 1 sitting here. Okay, what does that mean? Well, it can be written as 1 over 1, so a rise of 1 and a run of 1. So up 1 over 1, up 1 over 1, up 1 over 1, and let's draw the line. Okay, so we can see the point of intersection. Oh, that's silly, I'm changing the line's color. Oh well. Because the point of intersection's right here. And it looks like the x value is 2, and the y value is negative 1. If you wanted to write a sentence, the point of intersection is 2, negative 1. Okay. Let's look at a couple of special cases now. So one special case is parallel lines. So I gave you a couple of activities to do already related to parallel lines, but let's just check this out. So I made 2 lines here, and for the blue line, it has a slider, B, so the y-intercept can be a variety of different values. So I made this slider, and I can ask you, what's the point of intersection of these 2 lines? Well, there is no point of intersection, and we talked about the slope. You can see here that the slope is the same. Therefore, they're parallel. Therefore, they never intersect. There's another special case, and it's when the lines are equal. Almost got it. There we go. Ooh, so the two lines are right on top of each other now. It's hard to see them both. Too bad the colors don't mix. It would make a purple or something. That would be cool. Okay, so let's find the point of intersection. Well, that's a point of intersection. 6, 4, and that's a point of intersection. 2, 2, and well, that's a point of intersection, and that's a point of intersection, and that's a point of intersection, and that one, 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 and I think maybe it's starting to get mad at me. And that one, and that one, and that one. Am I running out of letters? I don't think it's letting me do any more. Oh, it's not on point anymore. Okay. And that one, and that one, and that one. Oh, L missed. There we go. And that one, 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 and that one. So if I asked you, what are the points of intersection of these two lines here? Can you answer that? Well, you can't give me a list of all these points. There's so many. You'd be here all day, all night. You'd be here until a million years from now and then beyond that, because there are infinitely many solutions. So when two lines are equal, there's infinitely many solutions. So these are the two special cases. The first one was parallel lines, and the second one was equal lines. Okay, so let's look at some examples and try to decide if they're parallel lines, equal lines, if we can find a point of intersection. So say we have y is equal to 2x plus 1, and y is equal to 2x plus 3. Well, looking at this, they both have the same slope. So therefore, they're parallel. No points of intersection. Okay, let's look at another example of two lines. Okay, these lines look a little bit different, but if I rewrite this equation and try to compare the slopes here, let's see. How am I going to rewrite it? Maybe I'll just do y equals mx plus b form because that's my favorite and I'm very comfortable with it. I can read the slope. Okay, so I moved over the 4x, and I'm going to divide everything by 6. And I'm going to save myself some space, and I'm going to reduce this. 2 goes into 4 twice, 2 goes into 6 3 times. Okay, so this is what we get when we rewrite the first equation. Let's see what we're going to get when we rewrite this equation. Moved over the 2x, divide everything by 3. Okay, so what can we say about this? These have the same slope, but they have different y-intercepts. So these are parallel to each other. They're not equal. If they're equal, they would also have the same y-intercept. That's something I didn't really talk about up here. Notice that these y-intercepts are different, so they are not equal. They're simply parallel but distinct. So again, this has no point of intersection. If they're equal lines, when you rearrange it, you would get the same numbers. So I could have so I could have these two lines. We know from the work that we just did over here that this line is equal to y is equal to negative 2/3 x plus 1/6, because we just did the work. I'm just stealing the same equation to make life easier. Okay, and now we can see that we have the same slope and the same y-intercept. So for this example, it's the same line. They're on top of each other. They always intersect. So we say infinitely many points of intersection. Okay, I hope that helps to make sense of the idea of parallel lines and equal lines and intersection of lines.